Welcome, everybody. So I'm going to start off with a question for you. I can't see very well with this lovely lights in my eyes, but raise your hand if you have ever built a website or a web app. That looks like almost everyone. Okay. I'm going to explain a scenario to you, and I want you to think about one of those favorite ones that you've built. Let's say you show it to me here at the conference. I'm impressed. I want to play with it. I get in the cab, head to the airport after the show, get on the airplane. They don't have Wi-Fi on this airplane, and I have to put all my devices in airplane mode. Raise your hand if you think that I can still enjoy all the awesome things that you built into your website or web app. I know there's a lot of glare, but I can only count one. Was there more than one? All right, so you're in the right room. I am Teri Chadbourne. I am a developer, advocate, and community manager, and I'm here to advocate for a development approach called offline first. Offline first is an approach that plans for the most constrained network conditions first, whether that's actual complete lack of internet in places in the world where the infrastructure doesn't support it, or whether that's us on the subway having a crappy time. It's a user experience that just works, regardless of which of those experiences we're talking about. And really, even for a novice developer, it's this user experience perspective that's really easy to grasp as simply a user of the internet. It's also a social movement that's aimed at democratizing access to data. And I'm really happy to be a part of the community that's building apps that work offline first. I'm actually a co-organizer of an event called Offline Camp, where we gather about 30 people in a cabin in the woods somewhere. We sit around and have unconference-style discussions about various aspects of offline first in a remote location, often with pretty crappy connections, somewhat intentionally, somewhat unintentionally. And after that, one of the most important parts of my job is to take the discussions that happen within that event and bring them out to the larger community. So when we're on site at camp, we're having small discussions, and then we come back and present to the larger group so we don't miss anything. And then I try to convince our authors to write for the Offline Camp, Medium Camp publication. And the editorial process is a bit of a bear. It involves a lot of nagging of folks, going back and forth, making sure they have what they need, that I'm getting what I need from them. And multiple editors need to work on these drafts together, as well as the writers. And we used to use a tool called Trello, which is awesome to manage our path. But the fact of the matter is that the steps really changed based on the kind of articles that were being written, and I wanted something that was more customizable. So a year or two ago, I decided to try building my own app to manage this process. It looks like this, and we'll take a deeper look in a minute. But it has a basic form, essentially. It's built with a form where I can add articles to the list that I need to keep track of. And it also has a page that will take all of that information that I have and generate a page that works for the author to see what they need. This updates dynamically based on what's found in that record. And all of this works offline, which is really important in my use case. So what we're going to look at today is how I put this together in a really beginner-friendly way. I was a pretty novice developer when I built this particular app. And I'm not going to tell you it was easy, but it was a lot easier than I expected it to be. And I'm here to introduce you to some of the tools that made it that way. So before we get started, I just want to hone in on this. One of the sort of core principles of offline first is that we're not going to treat an offline state as an error condition. We're going to make offline the baseline, and then we're going to work up from there and add enhancements when we have a better connection. So this is called progressive enhancement, and we really are going to treat all of that baseline functionality. That's the core. Everything else, icing on the cake. So let's start by looking at how we can handle offline data storage and sync. And we're going to try that using PouchDB and CouchDB. So what I've told you about the requirements for my own project that we're looking at right now seem a little bit contradictory. So I've told you that I need to be able to work offline. You know, I have a crappy internet connection on site. If I want to start the process there, it seems like I would have to store my data locally. But I've told you that I need to collaborate with my co-editors, which implies that we have to have the data in the cloud so that we can sync it back and forth and have access for multiple devices, multiple users. There's actually a way to do both of these at the same time. So we can do the local storage using a PouchDB, the remote storage using CouchDB, and then focus on this sync superpower between them. So we're going to start with a demo. As always, many fingers crossed. The benefit that I have over other speakers is that my goal, if I'm successful with this demo, I prove to you that offline first is awesome. But if the whole thing falls apart because Wi-Fi at the conference center is really bad, then I just prove that it's super necessary. This is lovely. All right. So I'm going to start us off in an incognito window in Chrome that has never seen my site before. And it can't find it right now because I haven't loaded it up. I'm using localhost. I haven't loaded it up yet. Now, I need you to remember this screen because I'm going to talk about it later, but I won't be able to get back to it later. So please note that this site refused to load the first time I tried to get to it without a connection. Oh, interesting. AV folks, how do we get the rest of my computer to show? I'm in Chrome on my computer. Did that work? Yes, okay, great. Thank you for giving me a heads up on that. All right, so here is the nothing that we were looking at together. Here's the website that won't load because we're offline. We've never seen the website before. This is expected. I need you to remember this screen. So what I'm going to do is start my server. And it's fine if you haven't, at this conference, you probably have. But if you haven't used Node before, that's completely fine. I'm just going to use npm start. This is the only thing that's remotely not front end in my presentation. All of my code is front end. And then I'm just going to reload this page. So you'll see here the main screen of my app, and I have 3 articles in progress in my database or completed. Really simple stuff here. I have a little bit of filtering, but essentially all this is a pretty basic application built on a form. And I can add new articles, and just because of my use case, I have a lot of fields that are going to appear based on what you choose in other fields. But essentially, we can just add any record. We can see that that has loaded here. And you see at the bottom that it claims I am syncing to a remote database. We'll take a closer look at that later. And what I've shown you so far is something that we can build pretty easily. And this would work just fine, the functionality we've seen, if I was the only one who needed to use it, and I was always going to use it from the same device. This would be really easy to do with something like local storage, for example. That's not the situation I've described to you. So let's see what happens when we bring someone else into the mix. So I'm going to pretend that this Firefox browser over here is my colleague Bradley, and I'm going to be Chrome on the left. He's going to be Firefox on the right. So let's load him up. He now has an internet connection. So this is his first time loading the page. So he immediately has, well, it looks immediate, not actually true, has access to all of the same articles that I've already written. And what actually happened there is that he loaded a completely new PouchDB in database browser that was empty, and then immediately synced to Cloudin and pulled down all of the records I had there. Cloudin is a hosted version of CouchDB, which we'll get into in a minute. So when we're online together, if I add an article over here in Chrome, I'm going to hit save on the left, but I want you to watch the screen on the right. Ready? 1, 2, 3, save. Did you see how fast that appeared on Bradley's machine? Now, these are totally separate PouchDB databases. I'm using Chrome and Firefox separately, so it's essentially using 2 different machines. That speed is the result of an offline-first design pattern. But what happens when one of us goes offline? So let's use the web tools here in Firefox to take Bradley offline. So he has a message that he's not syncing anymore. And if he tries to add an article right now, We can see it on his screen, but we can't see it on mine. It has no way to get up to our remote database and back down onto my laptop. What if I add one? I'm still online. Okay, so I can see that one, but Bradley can't see it. He doesn't have that connection. And if we look under the hood, this is my Cloudant dashboard. At the time that I built this app, I was working for IBM, which recently acquired Cloudant. It's essentially hosted and managed CouchDB. So this is my Cloudant database, and if we look at where it's at right now, so it believes it has the number of things on my screen here on the left. So it believes this is the number that we have, because it's never seen Firefox. But if we bring Bradley back online and refresh, now he can see both mine and his. And notice that it knows what order we wrote them to. This is showing the most recent articles first, and it knows that he saved his one from Firefox before I saved my latest one on Chrome, even though it wasn't online when we made that change. And that would be reflected in that Cloudant database as well. So how does this all work? Let's pop back over here. So the local storage is happening with PouchDB, which is an in-browser database inspired by Apache CouchDB. It's open source. It has an async API. It can use either promises or callbacks. It works across browsers, and it checks whether certain features are available. So for example, it will try to use indexed DB if the browser supports it. Otherwise, it'll use something else. And it's a JavaScript library. So that means that you'd use it like other libraries. For example, if you are accustomed to using jQuery, we can just reference it right in the HTML file before the files that depend on it. And creating a new PouchDB database is really simple. We just give it a name right here. And you'll see, if you look under the hood, that it has actually created that in indexed DB. You can see that. That's the Chrome developer tools you're looking at. And for that remote sync, we're using Apache CouchDB, also an open source product. It's a NoSQL document store, so not the rows and tables of the SQL world, but documents in JSON format. It has a developer-friendly query language, so if you've used Mongo but not Cloudant, it should look fairly familiar to you. It's cleverly named Mango to make you feel that connection. But the Couch replication protocol is better suited for offline applications, to the best of my knowledge, than the Mongo one is. So to create that CouchDB database, you can either do it yourself. If you know how to host a database, you can do it directly with Apache CouchDB. I didn't know how when I was doing this, so I used Cloudant for ease. But either way, you're going to generate an API key. These are things maybe you've done before. Set up your cores, and make note of that URL that has the admin credentials built right in. And you're going to have a URL that looks something like this that's accessing that remote database. To connect to it, all we're going to do is set up a variable that represents that remote database and say this: if the remote database exists, sync. That's how we establish a connection between PouchDB and CouchDB. It's very simple, and PouchDB is taking care of a lot of stuff under the hood. So then we need to set up continuous sync and listen for changes. So here, the option I have there, live true, means we want to listen for updates as they happen. There's a second option here that I should have used, which I'll look up for you in a minute, to make sure that once it fails, it tries and tries and tries again to reconnect itself. And on change, on any change in the database, this is a change to the PouchDB database, which would also be triggered by a change to CouchDB. It's going to run a function I wrote called update articles. Now, one of these notes, going along with the fact that we're treating offline as kind of the base state, is that being offline isn't an error if it's the thing we expect. So we want to just give people a heads up, use messaging that lets them know things are safe, so their data is safe offline. We're working on connecting it for you. If you haven't seen a JSON object before, this is essentially what it looks like, and this is the way that we transfer data with PouchDB and CouchDB. And we're going to use a unique ID here. This is common to a lot of databases, I think, but you need to make sure that this ID stays unique and stays consistent across all updates. And a timestamp is a great way to generate that ID. There are also revision markers with PouchDB. It's going to be generated by PouchDB, and you can't send it in on the first write, but on the subsequent write, you need to know what was the most recent revision marker, and you have to be able to pass that in. So you need to, in your code, to put some way to remember that. So I did it like this. I was using a hash as part of the URL that let me know whether I was on an editing screen where I was creating a new record or updating an existing record. So in the one case where it was new, I was creating a new date stamp and passing in no rev, that's the bottom section there. And if it was me editing an existing record, I was just grabbing the values that were already there for the ID and rev in a spot that I have kind of hidden and inaccessible to the end user. And then we're just going to save the data from the form as a JSON object, which you've probably done in some other contexts. So some of these are going to be the fields we don't let the user touch. Some of these are going to be grabbing values from that form. Now, writing documents to PouchDB is as simple as using this db put command. So you're going to put your article, which is that JSON object that I just had there, and then we can use promises here to do one thing if it succeeds and a different thing if that save fails. When we want to fetch a document, when we want to fetch all of the documents, so to generate that list on the main page where we saw all of the records in the system, we can use db.alldocs, and we have some options we can pass in. So it's important to note that if you don't tell it otherwise, it's actually going to it's going to do the sort order one direction or another. And if you have used timestamps, that's going to be chronological. If you choose to use something other than timestamps, you're not going to have that option. So here, include docs means that I want to get back the actual stuff that I put in, that the user filled in the form. As I'll show you in a minute, if you don't do that, it's just kind of some metadata about what's in your database, not the actual data. So you definitely want to use that. Descending true means please show me the most recent first based on the way I did my timestamps. And then I'm telling it that I want to pass in this doc, what's returned, .rows. So the data here you have to dig into a little bit. This is how data comes back. So you're looking for that rows, which is an array of all of your documents. And then within each document, you have some metadata and then a doc. And then you have the fields that you might actually be curious about, your title, your author, et cetera. So you just need to dig in there a couple of layers. And then we can do whatever we want with that data that's coming back. So what I'm doing here is just making a bunch of LIs on the screen. And I have some more complicated stuff in here to add emojis and all of that nonsense. But it can be as simple as you want it to do. We're just doing a for loop here to loop through that result. So that's how we're getting to this list of articles. But what happens when we click on a specific article? So we need a way to fetch a specific article, and we're going to do that with db.get. And you're just going to pass in the ID number that you want. And that's something that we can save. As we're writing that list, we can put that in a link. And then we can write whatever we want to the page. So here I'm just grabbing all of that data and converting it into filled-in form. So we can get that form back partially filled out. And that's how we get to a state like this. But when we want to touch that danger zone section and delete a record, what are we going to do? So we click the big scary delete button. We're going to use db.remove. There are actually a couple of ways to remove items in PouchDB. But this one is one of the simpler ones. We're going to say db.remove and pass in doc.id and doc.rev. Here, I'm just grabbing those from the form. And this is going to create a tombstone, essentially, in the database. It's going to add a deleted true to the fields in that specific document. And then if I've done things correctly, that's not going to show up in the future. And we should not depend on it being accessible to us in the future in CouchDB. So sync here is the offline first superpower that's making this all work. I can store and edit data locally while I'm offline. I can sync data to the cloud when I regain that connection. And I can share data from CouchDB across multiple users, across multiple devices, each with their own local PouchDB database. Please notice that I didn't have to do a single AJAX call here. Never did I need to learn how to do that. PouchDB is handling so much stuff under the hood that's making this really easy to do. So we've talked about data, how you deal with the data from your application while you're offline. But we're missing something. Because even if all that data was successfully syncing, I can imagine a case in which the page itself that has the button I need to click on to fetch the data, that page won't load. And that's why we need service workers to deal with caching. So the vital resources that make a page function, the JavaScript, the HTML, the CSS, also need to be available offline. Do that with those service workers. So let's try another quick demo here. So this is when I need you to remember what we saw at the beginning. You remember that when I first tried to load this page, it failed to load. We've seen that. Now let's see what happens in a normal use case. So here's a web page I built before I knew anything about service workers. It has no service worker in it. If I take down my internet, and again, in Chrome and Firefox both have ways to do this. In Chrome, I'm going to go into the inspector, application, service workers, and hit that offline button. I'm going to refresh the page. Who thinks they know what they're going to see? Who has seen this dinosaur before? Do you know this? He's a game. Raise your hand if you already knew this. Raise your hand if you're really impressed with me right now. Yeah? Thank you. A lot of you already knew that. Oh, so you're not very impressed with my jumping skills because I wasn't focused. You can jump over cacti, you can duck under pterodactyls. So when you're on a train and you have no internet, this is a good way to entertain yourself. But here, I'm gonna replicate that same process by bringing down my server. So this is fine. We're bringing it down with the server as opposed to in the app itself, because that's where we're getting those resources from: HTML, CSS, etc. I can't bring this page down, and that's because of the caching that's happening with the service workers. So if we take a little look under the hood here, it's really important to note that no app can work offline on a first visit. And when you think about it, this isn't our expectation. Even with native applications, we don't expect this. We expect one time to have to download the application from our app store of choice, right? So the first and offline first is not about your first visit working offline. It means that you're going to put the user first by, on every subsequent visit, loading cache resources first before you try to pull anything from the network. And the order here is really important. So service workers are a tool that runs in the background. They're separate from a web page. They enable modern browser features that we kind of associate with native apps: push notifications, background sync, caching. And they really enable lightning-fast, offline-capable page loads on all of those subsequent visits. Service worker has a lifecycle all its own. You register it, you install it, which is kind of giving it a list of what items to cache, activate it, and then it's really awesome, but it's also really hard to debug, at least for me. So registering a service worker is going to happen here in a quick script in my HTML file, or I can call it from another file. Navigator here means the browser. So if service worker is supported by the browser, then register this file, swjs, that I am also hosting here. Keep in mind, you need to put this service worker in the root directory of your application, because where it is defines the scope of all of the stuff that it can cache for you. And then in that service worker file, we have an event listener that's kind of waiting for it to install itself. And then it's going to try to open a cache named blog tracker if it finds it. Otherwise, create one by that name. And then I'm giving it a list of all of the files that I want to add to the cache. Now, this is where you have an important responsibility to cache the things that are essential, but only cache the things that are essential. Now, in my app, this is a shortened list to make it fit on the slide, but I've actually cached almost every file in my application. But you can envision that if you were working on a newspaper with lots of articles, maybe you only need the newest articles. There are a lot of a lot of scenarios where you can think of ways that you could limit the resources that you're using on that phone. Because a person who is offline might be also in a situation where they have really limited access to other stuff, space on their device, et cetera. So cache carefully. And then you're going to find that in the cache storage in this resource panel. So you can see in my app that it's cached all of these CSS, HTML, JavaScript files for me. And you can also see here that the service worker is activated. It does that itself. You don't need to do something to make the service worker activate, but you can listen for that activation if you want to. I won't go into it, but a case you might want to do this is if you're working with something where you're adding new things, like adding new posts to a social feed or something like that, and then you want to change what's in the cache, that would be the trigger that you'd want to use to do that. And then you'd also want to think about numbering your versions of your cache. So next we're going to do this thing that looks really scary and evil. We're going to intercept network requests as they come in. So we add this fetch event listener. So when the browser is trying to fetch a resource, it might be trying to fetch the HTML, the JavaScript file, we're going to listen for that event, and we're going to try to find in our cache the thing that's being asked for in that request. And then, if we have found it, we're going to respond with that item from the cache. If not, we're going to try to get it from the network. Note the order. This is super important. The opposite seems true. Like, it seems like we'd want to give them the most recent up-to-date information first, so we want to give them what's on the network. This is how we get into the Wi-Fi trap. Have you ever had that situation where your computer thinks it has an internet connection, but it's not doing anything useful for you, and you have to turn off your Wi-Fi to make it work? It's very obnoxious, yeah? So what's happening there is that it's looking for a resource on the network, and it refuses to admit that it is failing to connect to the network. So your user's staring at a blank screen. If you first use the cache data, load something, even if it's old, but load something immediately, then you can go to the network later and try to update that. You can build your code to do that. But your user is always going to have something there, and it's going to create this fast user experience that's going to work regardless of whether we're in a no network situation or just a crappy network situation. That's it for service worker. Like, these are the essential steps you need to take. So we've seen what we do with the data storage. We've seen what we do with the service worker. Gotchas here. So I'm at time. I'm going to flip through these quickly to show you what's in the deck that you can download if you want to look at things in more depth. This is my most important advice to you. Service workers are sticky, and that's what makes them so hard. I recommend that you implement service workers last. If you want to play with CouchDB and CouchDB, set that all up first. Get your app to where you want it to be, and then start playing with the service workers. And you need to learn how to clear those service workers. So learning to do hard refreshes, use incognito browsers, get familiar with Chrome dev tools. There are a lot of resources from the Google team. They're really focused on progressive web apps. And there's a magic button here, Update on Reload, that is highly recommended by Jake Archibald of Google and me. Simulate an offline experience. You saw me do this, but I have screenshots of how to do it in Chrome and Firefox. And then there's an audit tool called Lighthouse that lives right inside your Chrome browser that will let you test for a lot of things, including accessibility. But one of the things it tests for is progressive web apps. So a progressive web app is broader than just saying that something works offline. It must, by definition, be offline capable to be a progressive web app. But it also includes things like being installable to the home screen, so it feels more like a native app. There are a lot of standards there, and this is a really cool way to get an audit done and then find some specific recommendations for how you can improve there. I leave you with this. Offline first is not a specialized approach. You're not building specifically for low bandwidth scenarios. It's just a great design pattern, regardless of your anticipated audience. If I can do it, you can do it, so let's go do it, right? I have some resources here for you, but you don't need to jot these down. If you go to this one link, you'll find my repo, and you'll find links to all of those resources, past videos of my talk, slide deck. The slides are also in your scheduling app for this event. So if you want to snag a shot of that. And I also have cards up here that have that link on them if anybody wants to come grab one. I know my time is up, so I'm going to pull my stuff off stage and then go out to the back of the room. If anybody has questions, you can find me there. I think we're going to a break now. Thank you.